All right, so this is video 2 for 1.01 algebraic expressions. And in this one, we're looking at how to rewrite algebraic expressions. And everyone's taking notes at home here, I know that, in equivalent forms. By simplifying them. And yeah, usually we'll be simplifying them. Simplifying is a weird idea though, because some people think one thing is simpler, other people think something different is simpler. Just depends on what you're using it for, really. So thinking about this x plus x plus x plus x. Now, we're adding x to itself 4 times. And you know, mathematicians are like inherently lazy. And they're like, I don't like writing it so many times. How about instead I just write 4x? Because multiplication just actually means repeated addition. So when we write 4 times x, notice there's no multiplication symbol in there. When there's a number, it's called a coefficient, in front of a variable, a letter that represents some unknown value, usually. So when there's a number, the coefficient in front of a variable, we're saying multiplication. And multiplication just means repeated addition. So if we think of something like 3 times 2, what we're actually saying is we are adding 3 to itself twice. And so, whoops, that's not right. 3 times 2 is 3 plus 3, which is 6. So notice 3 times 2 is 6 and 3 plus 3 is 6 because multiplication is repeated addition. So we can rewrite x plus x plus x plus x as 4x. And this right here is called combining like terms. So I'm going to put this on the right. Combining like terms. And if there's no number in front of a variable, like here we have the coefficient is 4, if there's not one listed, then it's 1. So this is saying 1x plus 1x plus 1x plus 1x. All right, so that's important too. So let's see, what else is going to be an important, oh, here's something important. So let's talk about what that idea of a like term is. So combining like terms is the first step in kind of simplifying expressions. And so exponents are an important part of like terms. So we're looking at like terms here. And we're thinking about what are exponents. So notice that, remember I said multiplication is repeated addition, right? So 2 times x, this is a bullet, by the way. 2 times x we can think of as x plus x. But if we think of something like 2 times 3, it's going to be 3 plus 3. And that's 6, like we said before. You actually can also think of it as 2 plus 2 plus 2, because in this case, we're adding 2 to itself 3 times. So you can switch it around and look at it either way, and that's just fine. But when we think of 2x, we don't know how many times we're adding 2 to itself. So we couldn't write 2 plus 2 plus 2 because we don't know how many times to do it, okay? So we can just do x plus x there. Now, the next thing that's important to notice is this idea of an exponent, a power, okay? So x squared, what does that mean? Well, that means x times x. And in the same way that multiplication is repeated addition, powers are repeated multiplication. It tells you how many times to multiply the base by itself. So this is called the base, and I talked about that in the other video. And I think, no, I don't think that I did actually. So this x is the base, and 2 is the power or exponent. So let me just give those a little bit of a highlight. 2 is the power or the exponent, and x is the base. Okay? It's important to use mathematical language here. So one thing that I have students often kind of get confused about is they think that 2 to the third power is equal to 6. Now, you look at that. What are we saying when we say 2 to the third power? Because this is not correct. Not correct, okay? When we say 2 to the third power, we're actually saying 2 times 2 times 2. And this 2 times 2, well, that's 4. Oops, sorry. 4. And then we still have this times 2, so I need to make sure that I keep that there. And then 4 times 2 is 8. So 2 to the third power is 8, which does not equal 6. So be careful about exponents and remembering that it's repeated multiplication. So for that reason, we can combine terms that have bases raised to the same power, but not terms that don't. And let me give you an example of that. So something like 3x squared plus 4x squared, well, that's going to be 7x squareds. Okay? So we can combine like that. But we cannot say 3x plus 4x squared is equal to 7x or x squared. Nope, neither one of those work. Well, you can't quite see it. There you go. Neither one of those work. That's not correct. So don't make that mistake, please, of combining terms that have different powers. Not allowed. Likewise, so let's look at an example of combining like terms. Are there any questions up to this point? Oh, look at that. I like that. Nope, no questions for you. Thank you for engaging with me here. That's helpful. All right. So now these variables, x, y, and z, they represent numbers. I don't know what numbers they represent, but they do represent numbers. And they may or may not represent the same number. X might equal z. I don't know. I'm not sure. But what I do know is that this 5x and this negative 2x are called like terms. And this 3y, positive 3y, and this positive 1y are also like terms. So I can, and there are no other z terms, so there are no terms that are like that one. So I could rewrite this equation as 5x minus 2x is going to be, is going to be 3x. And then I have that that positive 3y plus 1y is going to be plus 4y's. And then I still have plus 3z. And so that's how we combine like terms. Now, usually We put them in order, alphabetical order, X, Y, Z, but we could just as easily have this be 4y plus 3z plus 3x. It's equivalent. They're the same value. So you could do that. Now, if we think about examples where we have some exponents, then if we have like 5x minus 2x squared minus x plus 4 plus 4x squared minus 10. Again, I find it helpful to highlight these that when they are like terms. So I'm going to highlight all of my x squared terms here with orange. And then I'll highlight my x terms with green. And I will highlight my constants. Constants are just numbers with blue. And so I could rewrite this expression as, and we usually put the term that has the highest exponent first as well. So we would have let's see, that's a negative 2x squared plus 4x squared will be a positive 2x squared. So combining those. Now combining our x terms, 5x combined with negative x, that is going to be 4x, positive 4x. And combining the positive 4 with the negative 10 will be negative 6. Now, if you have a hard time with positive and negative numbers, make sure you're using a calculator. That is absolutely okay. I highly suggest you do that. Now, we are going to, let me see how long we've got going in this video here.